Okay, let's now go into our next topic. The next topic which we have is this. Now, the first doubt which comes to our mind is how do we pronounce it? The word is pronounced as rendezvous. So, this is how we pronounce the word rendezvous. The second doubt which comes to our mind is what does it mean? The meaning of this word rendezvous is a meeting at an agreed time and place. Now, in respect of a ship, this basically means that if you want to meet up with another ship at a pre-decided place or a pre-decided time, it is called as rendezvous with the other ship. Now, this could be a scenario, say, for example, if you receive a distress message, the ship is in distress and is asking for your assistance. Now, the other ship is steering some particular course with a particular speed, and you want to meet up with that ship. So, in these rendezvous calculations, we will be able to find out how to meet up with the other ship. What course do we need to steer? What speed we need to maintain? It can be calculated using the rendezvous method. Now, the questions which come in our exams can be divided into three categories. It will make the solution of the question very, very simple. So these three categories are, the first one is when you want to rendezvous with another ship and there is no current in the area. So without any current. Second type is when there is current in the area, which is affecting the target ship and is also affecting your ship. And the third category is when there is different current at own ship location and the target ship location. So you have different currents at both the locations. So we will do these three types one by one. So let's go into our first type of rendezvous problem, that is rendezvous without current. Let's open up the chart where we will be doing these calculations. This is rendezvous without any current. Now, before we go into this topic, one thing which I would like to discuss here is that there are many methods which are available for doing the rendezvous calculations. Some people use radar plotting type of methods. There are other methods also which can be used. What I have tried to do here is I have tried to pick up the most simple, most basic method, which are very easy to understand and which help you to quickly find the solution of this question without any confusion coming to your mind. So these solutions are written down or done, keeping in mind the simplicity which we require. So let's start off with our first type of rendezvous problem. Now, beta, in these type of questions, the data which is given to us is the question tells us the position of both the ships, that is our ship and the target ship or the other ship. The speed of own ship is given to us. We know what is the speed with which we can maintain. We have the true course and the speed of the other ship or the target ship. It is told to us what course the other ship is steering and what speed the other ship is maintaining. In case wind is also present in the area, then they tell us the direction of the wind, and it is also given what is the leeway angle applicable. What we are required to find out is what course our ship should be steering to rendezvous or meet up with the other ship or the target ship. We are also required to find out what is our rendezvous position, meeting position, and at what time we will be meeting up with the other ship. So this is what we are required to find out. Now the first thing which we have to do is we have to plot the own ship position on chart. So let's plot our own ship position. Let's assume that our position is given to be here in this part. Let's name it as A, and the position of the target ship or other ship is also given to us. So let's plot the position of other ship also. Let's assume the other ship is at this particular location. Let's name it as B. Now we have to first of all join both these positions by a single line. So let's draw a line joining both the positions. We have this line AB on our chart now. Now we have to plot the course steered by the other ship. So the target ship, Bravo ship, what course the other ship is steering. Let's plot that course on the chart. We have the course of the target ship plotted on the chart now. Now on this course line, we have to mark the distance traveled by the other ship in 1 hour on this particular course. So we will open up our compass equal to the distance covered by the other ship in 1 hour. Center our compass at B and draw an arc. So you can see this arc. The radius of this arc is equal to the distance traveled by the target ship or other ship in 1 hour. Let's mark this point as point D, where the arc is cutting the course line. Now this Bravo delta is the target ship or other ship course and distance vector for 1 hour. Now from point D, we have to draw another arc. The radius of this arc, which we are going to draw now, is equal to the distance traveled by own ship in the same time interval of 1 hour. We have drawn the vector of other ship for 1 hour duration. So now we will be drawing the vector of our own ship for the same duration. So I open up my compass equal to the distance traveled by own ship in 1 hour. Keep my compass centered at point D and I will draw an arc. Now this arc, you can see here, I've drawn that arc. This arc cuts the line AB joining both the positions at a certain point. Let's name that point as E, equal. You can see E point here. Now let's join E and D, both these points. So you can see we have joined both these points, eco and delta. Now this vector which you see here, eco delta vector, is own ship course and distance vector for a duration of 1 hour. So you can see it here. We have the own ship course and distance vector for a duration of 1 hour on the plot or on the chart. Now we have to transfer this eco delta to point A. So we will use our parallel ruler, sliding ruler or set square, whatever tool you are using to draw parallel lines. Align it with eco delta and transfer it to pass from point A. So let's draw a line parallel to eco delta passing from point A. So you can see this line now. Parallel to eco delta, that is own ship course, and passing from our position, that is point A. Now this line which we have drawn is our own ship actual track for rendezvous with another ship. Now this line which we have drawn, it will meet up with the track of the target ship at a certain point. Let's call that point as C, Charlie. Now this Charlie is our rendezvous position.
So beta, have a good look at the plot and let me know any doubts coming to your mind.
एक्सप्लेन कर पोजीशन क्या होती है?
Ask again, beta. Beta, can you ask again? Anybody understood, beta, what she's asking?
No, sir.
Beta, you can type it out in the comments. So all clear up to here, beta? No doubts?
No doubt.
Okay, beta. Very good. This is the most basic and most simple of the rendezvous problems. The target is moving on a certain course and speed. We are at a certain location. We know our position, the target's position, and we need to set a course and set a speed so that we rendezvous, we meet up with the other target at the pre-decided position. So let's move ahead now.
So this completes our type 1 problem. This is a basic type 1 question. We have calculated our rendezvous position here on the chart. We can read its latitude and longitude. We have found our rendezvous position. Now, other things which we need to find out is the course to steer and the time to rendezvous. Now we can read out this course from the chart. This is the course to steer, and if there is any wind given, the leeway angle is given to us wind is present in that area, then this will be the leeway track. So in case of wind, we will have to counteract the leeway appropriately to calculate or find out what is the true course to steer for own ship to rendezvous with the other ship. If we are required to find out the compass course to steer, then we have to apply the variation and the deviation. And once we apply the compass error through variation and deviation, it will give us the compass course to steer. Now to find out the time to rendezvous, we have to measure this distance AC, Alpha Charlie. We know what is our engine speed. So this Alpha Charlie is the total distance to be covered by the ship for rendezvous. If we divide this Alpha Charlie distance by our engine speed, it will give us what is the time after which we will be meeting up with other ship. So distance AC divided by the speed of own ship gives us the time to rendezvous. Now you can also find the time to rendezvous using the target ship or other ship vector. For this, what you can do is you have to measure distance BC. This is the distance covered by other ship to the rendezvous position. So this distance BC divided by the speed of other ship will also give you the time to rendezvous. Now, whether you find the time to rendezvous using own ship speed and distance or the target ship speed and distance, in both the cases, the answer would be same. If there is any difference, a minor difference could be there. That could be because of plotting errors. Geometrically, whether you calculate it from your ship course and speed or the target ship course and speed, it will be the same. Now, there could be a special case in these type of questions, making the question a little complicated. What could be that case?
Go ahead, beta. Go ahead, beta. Ask. Okay, let's go ahead.
Now, if plotting work on the chart is not possible, what could be the scenario in which it is not possible? Either the positions of both the ships, own ship and the other ship or target ship, or the position of rendezvous, they are very, very far apart, or these positions are not on the chart. Whatever latitude, longitude is given to you, you check it and it is not coming on the chart. Now, in this case, how to solve this rendezvous question? Now, in this case, what we can do is, since we have the position of own ship and the target ship known to us, we have to calculate the range and bearing of the target ship from our ship using plain sailing. So by plain sailing from both these positions, we can find out the range and bearing of the target ship. Now, once the range and bearing of the target ship is known to us, we can make this entire plot or the triangle ABC on our answer sheet using a appropriate scale, exactly similar to how we do plotting questions. We do staggered and simultaneous plotting questions on our answer sheet. Exactly in the same way, we can now plot this triangle, the rendezvous triangle, on our answer sheet by using a appropriate scale. Before we move out to our next concept, uh, it is uh, very important that we understand one more complication or one more concept which is involved in this diagram, which we made in the rendezvous problem without any current. So let's understand this one more concept here. Some of the questions could be based on this particular concept also. Now, beta, we have seen that other ships' course and speed was given to us, and we wanted to find out what course and speed should we maintain so that we rendezvous with the other ship. So we made this plot on the chart. Now, in this plot, the line AB which you see, this particular line which I have highlighted, this line is also known as the line of approach or the relative line of approach. Now, what do we mean by this? What I mean is that if you are looking at this target on a radar which is on a relative motion, the radar is on the relative motion, you will see this target moving on the radar screen along this particular line Bravo to Alpha, and ultimately it will be meeting with your ship when both of you reach at point C. So this Bravo to Alpha is the line of approach or the relative line of approach of the target ship towards you. Now let's try to understand a little different scenario. Let us say that for a particular ship, they have given you the course and distance being made good or being steered by the target ship. And they have also given you own ship course and distance. Now what they want you to find out is what should be the line of approach of the target towards you. So the question is changed a little bit. Till now what we have done is that the line of approach was known to us. If you want to make a rendezvous, the line of approach has to be passing from our position. So that target has to approach towards our position. That's why we joined B with A. But in a different scenario, if you have other ships' course and speed, you have own ships' course and speed, you can easily find out what will be the line of approach on which the other ship is moving. So let me give you an example. Let's say the other ship course and speed was this one only, what we have mentioned here by vector Bravo delta. And let us say our ship course and speed was slightly different. It was not this one. So what was our course and speed? Let me mark it on the plot. Let us say the distance which we were covering in 1 hour or our speed was slightly higher. So our vector would be slightly bigger. This E point would not be here. The E point would be here. So what I have done is I have drawn the other ship course and speed vector, and where this vector has ended, that is at point D, I have drawn my ship's course and speed vector in reverse. These were the two items which were given to me. So I have plotted them following the same concept on my plot. Now, if I want to find out the line of approach of the other ship, how will the line of approach be? Now we can easily find out the line of approach if you join point B with echo and extend it. This is going to be the line of approach of the target ship. Once you have this line of approach known to you, you can also find the CPA and the TCPA very easily. How do we find the CPA? Now in this case, the ships are not meeting up. There is no more a rendezvous question now. It is basically radar plotting being done on the chart. So once you have this line of approach made on the chart, you can find out the CPA and TCPA. How can we do that? From your ship position, that is point A, drop a perpendicular to this line of approach. I've just made that perpendicular on the chart. Let's say this is point F. So from A, I have dropped a perpendicular onto the line of approach, and this meets the line of approach at point F. So this point F is the point where both the ships will be closest to each other. If you measure this distance alpha to Foxtrot AF, it will give you the CPA. So this distance A to F will give you the CPA, and you can also find out the time for CPA. Now this triangle which we made, Bravo, Delta, Eco, is a 1 hour triangle. So in 1 hour, the target ship is going to move from B. It is going to approach towards my ship, and it will at eco point. So this is the speed of approach. So we can easily find TCPA now. You measure Bravo to Foxtrot BF and then divide it by your speed of approach, that is Bravo eco, and it will give you the time to closest point, or TCPA. So we can find out the CPA and TCPA using this method. So there is a slight difference in approach. In the rendezvous question, line of approach is known to us. We know the CPA has to be 0, so the line of approach is exactly passing from our position. The target course and speed is known to us. These two were known. Let me mark it. This was known to us. The line of approach was known to us. What we were finding was this one. That is own ship's course and speed. Now, in this second concept which I have told you, the scenario changes a little bit. What we have is, we have the other ship's course and speed given to us. We have the own ship course and speed given to us. And what we want to find is the line of approach now. So when you plot these two, first you plot other ship's course and speed, Bravo Delta. Then you plot your ship's course and speed in the reverse direction from Delta point. And this point eco which you get, if you join Bravo to eco, this gives you the line of approach, which gives us the CPA and TCPA. So this is the extra concept which you should have in your mind and use it if required. I think there is 1 or 2 odd questions which have come in the papers related to this concept. One more thing which it tells you, if you look carefully, if the target ship is going to approach on this line, Bravo to Foxtrot, you see the target ship will be passing astern of you. Okay, if the line of approach was passing from our bow, see our ship is steering this particular course. So if the line of approach was passing ahead of us, so then the other ship will be crossing from our bow. But in this particular case, the line of approach is passing behind us. So the ship will be crossing from our stern, or in other words, our ship will be crossing ahead of the target ship. Our ship will be crossing from the target ship's bow, and the target ship will be crossing from our stern. That also can be seen as we draw this line of approach on the chart.
So beta, have a good look at this and let me know what doubts are coming in the mind.
Sir, now the line of approach is BF.
Right.
Okay, sir.
सर एक बार एक्सप्लेन कर सकते हो सर, थोड़ा कंफ्यूजन हो गया था।
किस चीज में कंफ्यूजन है बेटा, बताओ।
ये सेकंड पार्ट जो टारगेट बी विल अपीयर टू मूव ऑन दिस लाइन एंड जो आपने एक्सटेंशन किया ना सर वो परपेंडिकुलर ड्रॉ करके वो पार्ट.
Okay, beta. Beta, what we had done is we changed the question slightly. Now in this question, other ship's course and speed is given to us. So we know this vector Bravo delta. This is known. And they have also told us that our own ship, which is at position A, is steering a certain course with a certain speed. So our ship course and speed vector is also known to us. So what we had done is we plotted the target ship course and speed vector Bravo delta. From point D, we plotted our ship's course and distance vector for 1 hour in the reverse direction. So we will be able to get point E. So up to here clear?
Yes sir.
Now once you get this point E and you join Bravo to Eco, this is the line of approach of the other ship. So it means that the target ship on a radar which is on a relative motion would appear to move on this particular line. जैसे जैसे आप आगे travel करते जाओगे, you keep on steaming, the target ship will keep on coming on this line towards you. So this is how it will be approaching to you.
Okay
Okay,
sir.
beta? Clear?
Okay. Yes sir.
Okay. Or beta, any more doubt? Okay, let's go ahead, see the second type also.
Let's move on to the second type of rendezvous problem now. This is rendezvous with current. So the entire question remains the same with only one difference, that there is a current acting in the area, present in the area, which is affecting the other ship, target ship, as well as our own ship. Now this makes the question a little interesting. So let's see how do we solve. Now initially you have to follow exactly the same procedure which was done without current, which we have seen earlier, and we have to find out the point C. So let's quickly follow that procedure once again on the chart. We first draw the own ship. We first plot the own ship position on the chart, represented by point A. We plot the target ship position on the chart, name it as point B. Now we draw a line joining both the positions. Then we draw the target ship course steered line. This is the course which the target ship is steering. Now we cut off the target ship course to steer vector for 1 hour. So we have drawn this arc, named this as point D. Now from point D, we draw an arc equal to the distance covered by own ship in 1 hour. And you can see that arc here on the plot. Name it as point E. Now we join eco delta, and this eco delta gives us the own ship course to steer vector for 1 hour. Now we transfer this line eco delta to point A, and this meets up with the target of other ship. At this particular point. So this line which we have drawn meets up with the course line of the target ship at this particular point. Let's name it as C. Now this is what we had done in rendezvous without current. So we have followed the same procedure and found out this point C. Now the difference here is this point C is not our rendezvous point. Our rendezvous point is going to be somewhere else. The reason, we have current prevalent in the area, and the current is going to affect the target ship as well as our own ship. So what we do now is we also find out the time to rendezvous, exactly as we did in the previous question. That is, you can measure distance AC and divide it by engine speed of ownership, or the second option is you can measure distance BC and divide it by the engine speed of the target ship. Now, once we have the time to rendezvous, now we can involve the current in our plot. Once we have the time for us, we need to calculate what is the drift of the current for that particular time. Let us say, let's assume for making the question simple, that our rendezvous time comes to 3 hours. From this triangle ABC, the rendezvous time comes to 3 hours. So we are given the set end rate of the current. We find out what is the drift of the current in the 3-hour period. Now, once you find out
ये
the
टाइम कैलकुलेट करना है, ये AC से करेंगे ना सर?
This current vector to point C.
Go ahead, beta.
सर टाइम जो कैलकुलेट करना है वो AC से करेंगे ना सर? AC से ओनशिप
बेटा AC से भी कर सकते हैं और BD से ब्रेवो चार्ली से भी कर सकते हैं. आप AC को अपनी शिप स्पीड से डिवाइड कर दो, यू विल गेट द टाइम. एंड ब्रेवो चार्ली को अगर आप टारगेट शिप की स्पीड से डिवाइड कर दो, अगेन यू विल गेट द टाइम.
ओके सर, ओके, थैंक यू.
ओके, दोनों से कर सकते हैं. ओके, और बेटा और एनी मोर डाउट टिल हियर? Okay.
So I'm going to apply the current vector now to point C. The direction of this current vector is the set of the current, which is given in the question. And the length of this vector is the drift of the current in 3 hours, or in the duration what we calculated as time to rendezvous. Now current is represented, current vector is represented by 3 arrows. So let's plot the 3 arrows here. We have these 3 arrows showing this current vector. Now wherever this current vector is ending, let's name that as point F. So we have this point F on our chart. This point F, which we have found, is our rendezvous position now in this particular question. So we have obtained our rendezvous position. Let's now try to understand how this position F became our rendezvous position. For this, let's join point A, which represents our ship starting position, with this point F. Let's join them. So we have this line AF, Alpha Foxtrot, on the chart. Now this line AF is basically the course made good by own ship. This is the course made good vector. Now if you look carefully, the blue color vector here, Alpha Charlie, it is our course steered vector. This is the course which we are steering. If you remember, this eco delta vector was obtained using our engine distance. So this Alpha Charlie is our course steered vector. Charlie to Foxtrot, the red color vector, is the current vector. And we know the resultant of course to steer vector, that is the blue vector, and the current vector, which is the red vector, is the CMG vector. So the green color vector, Alpha to Foxtrot, which you see here, is our course made good vector. Similarly, if you join Bravo to Foxtrot, B to F, let's join it. So we have this line Bravo Foxtrot here on the plot. Now this line Bravo Foxtrot is basically the course made good by the target ship. If you remember, Bravo Delta was the course steered by the target ship. So this is extended up to Charlie, up to C point. So Bravo to Charlie is the course to steer vector for this duration of 3 hours. Charlie to Foxtrot is the current vector for the same duration. And Bravo to Foxtrot, the green color vector which you see, is the course made good vector of the target ship. So you obtain the rendezvous position. We can read out the latitude and longitude from here. We can read out this alpha Foxtrot vector. The direction of this vector will give us the course made good by other ship. And if you read the blue color vector here, the direction of the blue color vector here, either Alpha Charlie or Echo Delta, both are lying in the same direction. It will give you the course to steer for rendezvous. Now, if you want to obtain time to rendezvous, whatever time you had calculated earlier, that time is going to remain the same. There will be no difference at all, because this triangle Alpha Charlie Foxtrot is basically for the same duration which we had calculated earlier. We had found out the time to rendezvous using our course to steer vector and engine speed. So the time to rendezvous remains the same. There is no change in the time to rendezvous.
Okay, so beta, just have a good look at the plot. Just give me a minute, I'll be back. Okay, beta, let me know your doubts in this.
सर टाइम का बताना, एक बार टाइम सेम रहेगा?
ओके बेटा,
वो समझाना सर एक।
हाँ, टाइम बिल्कुल सेम रहेगा, देयर विल बी नो चेंज इन द टाइम। यू सी, हमने जो ये ABC ट्रायंगल बनाई थी, इट इज़ एग्जैक्टली एज वी मेड अर्लियर, इसमें कोई चेंज नहीं है। एंड द टाइम विच वी हैड कैलकुलेटेड सी हमारा इंजन डिस्टेंस CTS वेक्टर भी उसी टाइम के लिए है, करंट वेक्टर भी उसी टाइम के लिए है, एंड कोर्स मेड गुड वेक्टर भी उसी टाइम के लिए है. So exactly in the same time, the rendezvous position would reach at F.
Okay, sir. It will be same as C.
Yes, it will be same as C.
Okay, sir.
Okay. So shall we move on to the third type now? Third type usually doesn't come in the exam. It is only, I have included it only for your theoretical understanding. Third type का question आज तक exam में आया नहीं है. So that is different currents in the target area and our own ship area. So shall we go to the third one?
Yes, sir.
Okay, all right.
Now, before we begin, let me tell you that this is a very unrealistic kind of scenario, that you are having a different current in your ship position and a different current in the target ship position. Logically, may not be right, but if you face this type of question, though it rarely comes in the exam, but if you face this type of question, we can easily find out what will be the rendezvous position as well as the rendezvous time. So let's see how do we solve. Now, first we have to plot the own ship position on the chart. So let's assume this is where our position is. Let's name it as A. We have to plot the target ship position. Let's assume the target is here, and we name it as point B, and we join them with a line. This is exactly similar to what we had done earlier. Now what we do is we have to make the course distance and current, course speed and current, or the course made good triangle for target ship for 1 hour. So for this, what we do is we first plot the course steered by other ship. You see this blue color vector here, Bravo Charlie. This is the course steered by the other ship. Let's mark it with a single arrow. Now from point C, I plot the current vector. This is the current which is given to us in the question, and the current which is acting at the target location. So this is the current vector here, the red color vector. Let's mark it with 3 arrows. So we have the current vector with 3 arrows. Wherever this vector is ending, let's name that point as point D. Now, if we join Bravo to Delta, this Bravo Delta basically gives us the course made good by the target ship. So this completes the course made good triangle of the target ship. All this information is given to us in the question. We have the course steered, the engine speed of the target ship. We have the current which is present in the target ship location. So we can easily plot these on the chart and find out the course made good by the target ship.
Up to here is clear, beta?
Yes, sir.
Yes, sir.
Okay, all right.
Now the next thing which we have to do is we have to apply the current vector acting at our ship location. You see the currents are different in both the locations now. Target ship is facing a different current and our ship is experiencing a different current. So now we have to plot the current which is applicable at our own ship location at point D in the reverse direction or opposite direction. So let's plot it. Let's assume the current which is given to us at our ship location is northerly current. Let's mark it with 3 arrows. So we have the current vector plotted at point D in the reverse direction, and wherever this current vector ends, let's name that as point E. So this eco delta is the current applicable at our ship location. Now in the next step, we will draw an arc centered at point E and having a radius equal to the distance traveled by own ship in duration of 1 hour. So I open up my compass equal to my engine distance in 1 hour, center it at E, place it at point E, and I will draw an arc. So you can see this arc being drawn here. It cuts the line AB at a particular point. Let's name that point as point F. Now we join F with E. So we have this line now which is joining F with E, Foxtrot Eco. Now this vector, Foxtrot Eco, is basically our course steered vector. You see, we have opened up our compass equal to the engine distance traveled by own ship in 1 hour. So this Foxtrot Eco is our course steered vector. Now, if we join Foxtrot with delta FD, let's join it. This vector FD, which we are seeing here, is basically our course made good vector. As you can see here, the blue color vector Foxtrot Eco is our course steered vector. The red color vector Eco to delta is the current which is applicable at own ship location. And the resultant of these two, that is blue and red vectors, is the green color vector Foxtrot delta. The resultant of CTS and current is the course made good. So this is the course made good vector for own ship. Once we have this course made good vector for own ship, we now transfer this course made good to point A. So we place our parallel ruler, align it with FD Foxtrot vector, transfer it to point A and draw a line. Now this line passing from point A will meet up with the course made good line of the target ship at some particular point. This line basically represents the course made good by own ship, and the point where it meets the course made good of the target ship, let's name that as point G, Golf. Now this point G or Golf is the rendezvous position in this particular case. So we have the rendezvous position here. Now to find out the time to rendezvous, we can calculate it By measuring this distance alpha golf, we measure this distance from the chart alpha golf, and we divide this distance with our speed made good. Our speed made good is available from this FD vector. You see, we made this vector triangle for 1 hour. So FD, which is a vector having a duration of 1 hour, represents our speed made good in 1 hour. So if you divide alpha golf distance with FD, which is our speed made good, we can easily obtain what is the time it will take for our ship to reach the rendezvous position. Now this time to rendezvous can also be found using the target ship data. You can measure distance Bravo Golf. This is the distance made good by the target ship to rendezvous position, and divide it by the speed made good of the other ship, which is Bravo Delta, and you will get the time to rendezvous.
So beta, have a good look at the plot. Let me know the doubts.
सर ये डीई करंट कैसे लगाया ये समझ नहीं आया.
ओके बेटा, बेटा जो करंट हमने अज्यूम किया है एट आवर लोकेशन, दैट इज नदरली करंट. सो हमारा शिप ए लोकेशन पे है, ए पोजीशन पे, एंड द करंट विच इज एक्टिंग हियर इज नदरली करंट. सो हमने इस करंट को डी पॉइंट से रिवर्स में लगाया है. ओके, you see it is applied to the point D in the reverse direction. Current तो northerly है, but we have come southwards from D. So why have we done it like that? हमने इसे reverse में क्यों लगाया है? That will become clear when you complete the plot. जब आप plot complete करोगे तो आप देखोगे कि हमारा जो CTS है FE, that combines with the current which is ED, eco delta, to give us the CMG FD. Okay, so this is a step which you will need to memorize, which you will need to remember.
Okay, sir.
Okay, so what you can do is you can take a screenshot, keep it with you, and just revise it once. If it comes in the exam, though it very rarely comes, if it comes, then you have a backup. You know how this question is to be solved. Okay, beta, done?
Yes, sir.
Okay.